Hey everybody, this is Brad Dyke reaching out to you. My two-part video for this week is going to be on the same topic, and that is really cool stuff because my Dell R730-DX chassis, which I've been using for a few years now, have been showing their age and some difficulties and compatibilities and things like that. So I decided it's time to consolidate and let's build something new. So that's what we're going to do. I've actually decided on the Dell RX730DX chassis. It's 24 disc arrays here on the front with USB integration on the far side here. And this chassis was empty when I got it. And that's the secret sauce about this particular project. So what I'm doing here is I'm going to be that technician lab guy who's going to say, you know what? I'm not going to buy somebody else's server. I'm going to make my server from OEM parts. And that's what I've been doing. So I've been getting parts and pieces from different sources, and I have begun to put this stuff together. And I'm using OEM manufacturing warranties or limited restricted warranties. My goal is to have something I can work with here and use my own processors, use known good equipment, memory, and so on, so I could build this. So this is an empty Dell R730-DX chassis, and it didn't have much in it. It only has one thing in it right now, really, and that is the motherboard I got for it, and a couple of in slots and some cabling. As you can see, there's no busing, there's no interface here. We have no daughter sets, no NICs, no riser cards, no bus, and over here I bought a bus, which is right here. And I did put the RAID card in, but I'm going to change that for a 730p, I think, down the road. But the reason why I went with the 730 is based on a couple of reasons. Now, I understand 2 or 3 people out there already done a little bit of a write-up on the DX730 series. Now there are 2 different types. There are the R730 straight, and then there's the R730DX. And the other version has a base for up to, I think, 18 discs, but is more of a media style server, not necessarily a capacity media server like the DX series is, with the 26 2.5 inch disc capacities, and it will actually this time boot off of NVMe. That was what I wanted, not using SSD discs. I wanted to use the NVMe as my principal because I want to get into that high performance RAID sync. And the only way to do that is to build something that can meet that requirement and is compatible for those higher levels. Now, this isn't the only thing I had to get. I also had to get like heat sinks, and I do have the 2 processors because this chassis actually starts to catch up to my current workstation that I use for my home system, which are the 6300 series V4s Intel processors, and this guy can support those as well as V3s. And it has a decent range of processors and stacks. Now, some features that I wanted to make sure I carried over. So I still wanted the 12 slots per processor, and I wanted the upgraded 12 gig bandwidth cables from the 6 gig bandwidth cables that come with the 720. So they've got a higher rating. I'm still going to build out. I'm going to be putting in the SD card reader, and of course the paired busing for the spare 2 slots in the back right here, and they go right down in here. That's where that bus goes. And of course our Razer cards, and here is one of my favorite cards in the whole wide world, a 10 gig / 2 1 gig port daughter card, and it frees up all my PCI slots. And also, if you noticed here, that in specific daughter slots for the PCIe cards, you actually have power out for putting a substantial GPU into the equation if you want to add the GPU into a Linux paired cluster with the CPU. So it still has all the byte power. It's got the extended PCIe full here, which is really important, along with the 2 standards. And it has basically all the makings to be a really good platform. So some of the things you do when you order parts and pieces, and it's a very important detail, is you need to make sure that you test your components within the window of return. You also want to test the components of your bays, these areas here, to make sure that they are workable and they're not distorted or damaged in some way, because that does happen, and people sometimes don't tell you these things as they sell this stuff to you. So take a compatible drive caddy and make sure that your drive bays are working well. This one's a little sticky, I think. Not sure why. I'll have to investigate that. Oh, there it goes. And you get your, make sure that you're getting a piece of quality equipment. If not, ask for a swap out for a replacement if they've got the spares. And this chassis has proven to be pretty good in regards to handling, the bays and making sure everything is right and that everything is working correctly. So what I'll do here is I'll preliminarily put some additional parts on, show you guys what we're doing, and kind of get you, into the same mode I'm in. Now, one thing that's really difficult also is when you do cable connection sets, these are very delicate interfaces. Look how thin that one is right there, opposed to your knobby knocker, fiber channel, or in this case, SAS connectors. Take the time, preset your cables first, or if you can, as you can see what I've done here, is I put the adapter fitters on to make this guy a little easier to install. So what I'll do here in a second is I will flip around and put this cell phone on a stand so that we can see what's going on. Okay, so we've got the position in place now. I want to start first by making sure our bus channel is good. And let's take a look at the bus channel. This is a rare picture. You don't usually get a chance to see this in this position. But this is your controller bus chip, and it gets hot. So it has its own heat sink, as you can see here. And it's designed to dissipate and functionalize for the segmentation effect that occurs on these different channels. Because when you look at this, this is not a single channel. This is 3 separate channels. And they've actually got them broken down, and then they sequence them on the bus so that they can go out their ports, which are right here, giving them the ability to do quite a bit performance-wise. Now, this daughter card will go in this case, at a slight angle for placement, but I also need to make sure that my connector heads are getting put on first at the bottom, because if I don't do that now, I'll never be able to get my fingers in there to put them on later. And let's see, we've got one more right here. There are 3 of them on the bottom, which we need to make sure get snapped on right. Yep, that's good. And then what we'll do is we'll start to slip this into its place. Be careful of the delicate wires on the end. You don't want to damage them, but you also got to get it in the right place so it's sitting correctly on the system tray in this case. There are a lot of cables down here so they can get in the way. Okay, now we got a good fit. So now I can attach the 2 most difficult parts, which are the ends of the bus card itself. Okay, that one's on. And then this one's really fun because it's an edge. So it has to be fit in just right and put in position before you can lock the edge in place. It's not fun, let me tell you. I need my glasses. Where are the glasses? Oh, there they are. Okay, so I'll get this in place. Make sure we have it right. Push it in. Kind of tricky. Now if you don't get this right, then you can't power the unit up correctly. So you have to get this correctly in place. Get a forceps. Okay, so to just give you an idea how small this is, if you look right here, you should see where my scissors are pointing. It's a very small micro edge. There it is, you see right there? That little tab on it, right there. Okay, so that's an edge set up, and that's, I have to genuinely say, is the most difficult connection on the whole board, because if you don't get it aligned correctly and they don't make proper contact, they are linked to the VGA and the USB output on that side of the channel, and over here on this side, on this, you know, far, if you want to look at it from the left side, is the daughter snap in for the power stage connector, which is right here on this far end, which you can't see from this vantage point. But I'll give you that vantage point here, because this is the power connector edge right here, and then it goes to these controls on the front. So you need to make sure that you're bringing them all online correctly. Now, most of these cables come with a chassis in pre-configuration, and I'll show you that with the 1790 board I have coming next. That's the next pet project, and it's even more bare bones. But in this case, what I did is I placed the motherboard in place, started sizing stuff up, and now I can get myself to a good place where I'm able to start putting the peripherals on. So that I thought would be a good video for us here. So here I'm putting the SD reader, an SD card reader. That's for like security template keys, and or if you want to use an SD card for booting, you can. Hang on a second. Unfortunately, the chassis came with aluminum screws, and aluminum screws do not respond well to magnets, because they don't at all. That's okay. So I'll put this on and in place, and then it's got a Y expander connector on it, which I'll put on now. You've got to squeeze it from both sides gently, and it will slide into place and lock into place, as you can see right there. Right there. So these two endpoints here you have to squeeze in regards to how you want to position that. Now, the next thing I can put on now, at this point, is going to be the 210 gig, 21 gig RJ45 daughter card. Now, key thing about this is when you're putting it in, these are the screws you have to mount right here. But this is the pressure point you have to push to get the edge correctly seated. And if it doesn't flatten out correctly to screw in, you do not have it in the right place. So I'm going to put that in now. Going ahead and securing it now. If things aren't lining up correctly, they will not securely go down. So make sure that they're lining up correctly. Remember, you don't want to force anything into place. If it doesn't basically gently go into play, don't force it. Okay, there it goes. It snapped. So the screws, align it and keep it in the right place, and then push your fingers down on that gently to make sure that you get a snap, which I did get. Now, next thing we're going to do is we're going to put the backdoor dual array set up here, and we'll get this in place. First thing I have to do is to get it to be completely connected up here. Basically 3 sets of proprietary cables that connect up to this. You only go on in so many ways. It's got a slide lock track, and if you get everything in place, it will snap right into its home. Which in this case it is not doing that. I wonder why. I think I know why. Because this one corner's off. Alright, there you go. Now you're good. Oh shoot, yeah. Sorry, I forgot. One also very important detail here to recognize is there's a sleeve lock here too. Let me show you what I'm talking about. Right here, you got your 2 lock ends and your third one over here, which cause you to slip it into place. But there's a little indentation right here, a little hole, and there's a sleeve that goes in there that locks it into place before your lock will kick and properly lock it down. So if you don't know that detail, it's going to get you, and you just can't seem to get it in there no matter what you do. Now what we do next is we look at our daughter car sets. We can put these in now. There's one. It's one PCI bus that's installed. And now that I've got my NIC card in, I can now install the reverse PCI slot, which means it goes right in here opposed to over in these 2 bays. Line it up correctly, lock it in place. Now, if you look, you'll see the PCI slots on this side. So the card adapter has to go here, and it's a good spot for an NVMe card, don't you think? Lots of ventilation. Something to think about. I have to research the bus release on these to make sure that I know which one that's the true full-blown PCIe slot 16, so I can take advantage of that. Now we have the how would you say, the short PCI base. This is the large here, full-size cards. That would take like a video card. You could put a video card in here, and use the adapter power output, which is not present on this one. There is no power adapter here, unlike these 2 which do have them. If you see here, there's one here and there's one here. But this is designed specifically for the smaller base cards, NICs and so on. And now that's in place. So now that I've got my bays in place, I am now going to go ahead and populate the bays to make sure that I got what I bought for it, right? And it looks like it went into play. Good. All right, good. Put another one in. Yeah. They seem to be holding. Got a little bit of drift in it, but it's going in deep enough, so I think we're good to go on that front. Okay, let's make sure those are right. Make sure this is correct. All right. Back there. Now I'm connecting up the bus connectors, and I'm connecting up the PCI slots. Make sure they're in. So the SAS connections are going in the correct order, and they are mounted. The fourth channel, if you notice, is 1, 2, and then 3, and then the fourth channel is missing. Which you can't see that. Let me adjust the right here. You have your 1, 2, 3, 4 channels, but this channel's been redirected to here for these 2 back cards, and that's okay. You're just sparing the disk pairings out across 3 channels, and that's why you've only got 1, 2, and 3 channels on the front anyway, so you're okay. You're not sacrificing bandwidth, which is a very important detail. We're going to connect you up. Okay, so the 2 bus set cards are good. That cable is good. That one is good. That one is good. Always double check to make sure they are good and secure. And okay, now that leaves now the Xeon heat sinks, which of course have been prepared. If you can look at them, they've been prepared for their new thermal grease, which will be applied on their system. And then also the additional component, which is the processors. Let me reach over and grab those. Okay, we have our Xeon processors right here, which will go into their bays. One thing I will do, though, I want to make sure that I have the right ones, because I have many. 2640s. Yep, this is it. So I'm going to start off with 2 2640s, version 4s. These have already been paired, and they ran on my computer in my office for many years. So I can go ahead and start preparing that up here. Give me a second. Stupid spacer. It's got to go. Okay. All right. Trying to make sure we get it in the right position. The chips are keyed, and they're also in reverse. So you have to be very careful how you go about doing this, because you don't want to put the chip in wrong. Okay. Now you want to double check again that the pin matches are correct before you bring them down and close them up. All right. All right, so they are set. And then we have our thermal grease. And you have a dime size in your thermal grease placement each time. You don't need any more than that. This stuff gets pretty spread out pretty good. And this is designed for just 2 CPUs anyways, so that's used. And now we can place the heatsink into its home. And remember, you have to go across when you stage these. Usually go about 4 turns each. And if you do it this way, get those first 2 screws in good placement, then you go to the other side, and you can stage that side, and get those turning. And this will evenly spread out your thermal grease across the head of the processor. If you go left to right only, to tighten down things, you'll have problems. So we are having a problem here, because one of the screws is not lining up correctly. And so we'll make sure, by tightening the others down, that we will have a good fit on this last one. Okay, good. Now we'll do it again. I always like to get the lower profile first, because they like to be a pain. Alright, and that is done. And everything is snug and tight. It's going to give me the guarantee of good heat distribution. The only one that doesn't want to go in is this one. Okay, it's in there now. Now I'll put the base back in for the RAM slots for airflow control. You do need these. So if you don't have them, get them. They don't cost much. They're fairly cheap and they work. All they do is generate air restriction the right way. Okay, so I don't have memory yet. It hasn't come in yet, so that'll be my next stage, is to put memory on board. I'll make it fairly simple. We'll do probably 32 gigs. My current DX 720 has, I'm sorry, my RX 720 has 113 gigs of storage, and I'm going to miss that, but it'll take me a while to get up to that same capacity with these newer units because the memory is a little bit more expensive. But the good news is everything is fitting correctly, and with a couple of gigs of RAM on board, say 32, 64, 74, or 96 or something like that, we will be able to get this fully tested to make sure it's running. Now, what I'm going to do is I'm going to show you some other little hidden gems here that people may not know about, but are really cool to know. Let me move the camera real quick. Okay, so on this motherboard, as you can see it, all the setups and stuff like that, if you have what's called a mini USB 3.0 standard, that's a 256 gig or a 512 gig memory stick, there's a little tiny little secret here that nobody doesn't really know about. But if you look right here, right down there, you have an internal USB 3.0. It's great for toggles. It's great for boot OS. If you really want to get cheap and all you want is your disk to be used for storage, you can pair that up with the SD card over here as well, and that can give you some decent resourcing. But we're not doing that. We're going to be building a high performance, high cache ratio using SSD drives and NVMe capacity to get this bad boy cranking so I can do my virtual machines, my home services work, everything that which I have on this platform itself. And so if you look over here, I have one right here operational, and I have another one here that's the one I'm going to replace. And it's going to be providing me the bulk of my drive bays and chassis and caddies and all that good stuff. But as you can see, that is a 720 there, and same with this one. And of course that one's running pretty hard and heavy right now. Over here, this is going to be slightly better in regards to response and capacity. I have more compatibility, and it's just downright fun to make a server from the chassis up, but be in a manufacturer's format. Now, most of us people who know this stuff for many, many years, some call themselves gurus, I don't, they will build what we call white boxes. And those are just chassis with PC motherboards and stuff like this. That is not what this is. This is a telco level equivalency server platform, and every part and piece in here is a Dell component, and you have to go looking for each and every one of the Dell components to put into this empty chassis, and making sure what you got is going to work for what you want to do. So this one is built for storage and processing. I'll eventually change out the core processors to probably 2 24 cores for 48 total, like I have on my machine on my desk, and that will give me all the VMs that I need in a single box. Now, yes, this is a single point of failure, but I have a dual pathway and storage capacities. I've got dual PDU power outputs. I've got a dual bus motherboard, which means I could lose 50% of this motherboard and it will still keep working. Everything's redundant except for the fact I don't have 2 of these boxes. Now, with that being said, the key detail here is that you have yourself some fun. And that's what I'm doing with this. You know, I had nothing here. I went out and I did a lot of buying and strategizing how I'm going to do the buying and so on to get what I want. And then I got all the parts and pieces to come in here, and then I'm generating the video. And that's what I'm going to talk about in the second video that I'll be presenting, is how to buy to build your own when it comes to eBay or other providers out there. And you want to do it right, because when you don't do it right, or you find out somebody gave you defective hardware, or a channel bus is broken, you know, so only 2 out of the 3 channel buses are working, and if you didn't test them, if you didn't coordinate it correctly when you bought this stuff, you're out of it. I mean, it's yours and you got to go buy another one. But if you do it within the swap out warranty agreement time period of your purchase, you will find that you will be happy, because you can always return the part, they give you another part, and voila, you're in great shape. So with that being said, this is Brad Dyke. I'm going to sign off on this one. I have another video to make, and it's going to talk about how did I go about doing this. How did I strategize to get all the parts I needed in the right sequence, so that when I'm ready to do all this stuff, I can test all the hardware effectively and make sure that the hardware is good, so my return policy will work out best for me. So that's what I'll be talking about in my next video. This is Brad Dyke signing off. God bless and have a great weekend. Take care.